Welcome to this comprehensive deep dive into the Amazon SageMaker Python SDK version 3. In this presentation, we will explore the entire lifecycle of machine learning on AWS, from training models to deploying them at scale. Let us get started.
Here is what we will cover today. First, the SageMaker AI Platform Overview and SDK v3 architecture. Then, training jobs using the new model trainer. Next, supported frameworks and built-in algorithms. After that, model deployment with Model Builder. We will also explore all 4 inference options. Then, we cover MLOps with pipelines and model registry. We will look at cost optimization strategies. And finally, production best practices for security and monitoring. Amazon SageMaker AI is a fully managed machine learning platform from AWS. It provides tools for every step of the ML lifecycle. You can build and label training datasets with built-in tools, train and tune models using managed infrastructure, deploy models with a single API call, and monitor model performance in production with automated drift detection.
The SageMaker ecosystem is vast. SageMaker Studio provides a unified web IDE for development. Pipelines enables you to build automated ML workflows. Feature Store manages your ML features with online and offline storage. Model Registry tracks model versions with approval workflows, and Experiments with ML Flow integration helps you track and compare training runs.
The SDK v3 introduces a modular architecture split into 4 PyPy packages. SageMaker Core handles low-level resource management. SageMaker Train provides the unified model trainer for all training jobs. SageMaker Serve includes Model Builder for deployment and inference. And SageMaker MLOps covers pipelines, model registry, and orchestration. This modular design gives you better IDE support and smaller install footprints.
If you are coming from SDK v2, here is the migration map. The estimator class and all framework-specific estimators are replaced by the unified model trainer. The model class and its framework variants become Model Builder. The predictor class is replaced by endpoint.invoke. And framework-specific configurations are now structured config objects like compute, source code, and output data config.
Let us set up the development environment. First, install the SDK using pip install SageMaker. You will need AWS credentials configured via the AWS CLI. Then, create a SageMaker session and get your execution role. The session manages all AWS interactions, while the role grants SageMaker permissions to access your resources, like S3 buckets and ECR images. Now, let us dive into the heart of SageMaker, training jobs. The SDK v3 introduces Model Trainer as the single unified class for all training operations, replacing the many framework-specific estimators from v2.
The model trainer uses structured configuration objects. The compute config specifies your instance type, count, and volume size. Source code defines your training script, source directory, and dependencies. Training input configures your data location in S3 with content type. Output data config tells SageMaker where to save model artifacts. And stopping condition sets the maximum runtime to prevent runaway costs.
Here is how you create a model trainer. Import model trainer from sagemaker.train along with the config classes. Specify your training image URI. Pass your IAM role ARN for permissions. The compute configuration gives you fine-grained control over your training infrastructure. Choose from dozens of instance types, from cost-effective M5 instances to GPU-powered P4D instances. Set the instance count for distributed training, configure the volume size for data storage, and optionally enable managed spot instances to save up to 90% on training costs.
Configure your training script with source code and your data with training input. The source code object specifies your entry point script, source directory, and any pip dependencies. The training input points to your training data in S3 with content type and distribution strategy. You can use fully replicated to copy data to each instance, or sharded by S3 key to split data across instances for distributed training.
Launch the training job by calling trainer.train. Pass your input data channels as a dictionary. The train channel and optional validation channel map to directories inside the container.
Set wait to true to block until training completes, and logs to all to stream CloudWatch logs. The return training job object gives you access to model artifacts, final metrics, and job status.
Understanding the training job lifecycle is important. First, Sagemaker creates the training job and provisions EC2 instances. Then it downloads your training image from ECR. Next, it copies training data from S3 to the instance. Your training script runs with the hyperparameters you specified. Once training completes, model artifacts are uploaded back to S3. Finally, the instances are terminated and you only pay for the time used.
Sagemaker supports all major machine learning frameworks and provides dozens of built-in algorithms. Let us explore what is available.
Sagemaker provides pre-built Docker images for all major frameworks: PyTorch for dynamic deep learning and research, TensorFlow for production-grade ML at scale, Hugging Face for transformers and large language models, XGBoost for gradient boosting on structured data, and scikit-learn for classical machine learning algorithms. Each framework uses a specific training image URI that you pass to Model Trainer. Sagemaker also provides optimized built-in algorithms that require no custom code: Linear Learner for regression and classification, XGBoost with a highly optimized distributed implementation, K-means for clustering tasks, Deep AR for time series forecasting, Blazing Text for word embeddings and text classification, and many more, including PCA, Random Cut Forest for anomaly detection, and image classification. SDK v3 introduces specialized fine-tuning trainers for foundation models. SFT Trainer enables supervised fine-tuning with your labeled data. DPO Trainer implements direct preference optimization for alignment. RLAIF Trainer provides reinforcement learning from AI feedback, and RLVR Trainer supports reinforcement learning from verifiable rewards. All of these support LoRa, or low-rank adaptation, for parameter-efficient fine-tuning. Here is an example of fine-tuning with the SFT Trainer. Import SFT Trainer from sagemaker.train. Specify the base model ID from the Hugging Face hub. Configure your training data in S3. Set the LoRa configuration for parameter-efficient training, specifying the rank and target modules. The SFT Trainer handles all the complexity of distributed fine-tuning for you. For large models and datasets, Sagemaker supports distributed training. Data parallelism splits your training data across multiple GPUs, with each GPU holding a complete copy of the model. Model parallelism splits the model itself across GPUs, essential for models that do not fit in a single GPU memory. Sagemaker handles the communication and synchronization between instances automatically. Once your model is trained, the next step is deployment. SDK v3 simplifies this with the unified Model Builder class that handles the entire deployment pipeline. Model Builder follows a three-step workflow. First, build. Create a deployable model from your training artifacts. Second, deploy. Provision an endpoint with your desired instance configuration. Third, invoke. Send prediction requests to your live endpoint. Model Builder can accept a model trainer directly, chaining training seamlessly into deployment. It handles container selection, model packaging, and endpoint configuration. Here is the deployment code. Import Model Builder from sagemaker.serve. Create a Model Builder with your Model Artifacts S3 path and role. Call Build to create the model. Then deploy with your endpoint name and instance type. The deploy method returns an endpoint object that you can immediately use for predictions. One of the most powerful v3 features is training. Pass your model trainer directly to Model Builder. This eliminates the need to manually locate model artifacts in S3. The Model Builder extracts the training output automatically. Build and deploy in just a few lines. This streamlined workflow makes it easy to go from training to production in minutes. Sagemaker provides 4 distinct inference options, each optimized for different use cases. Let us explore when to use each one. Real-time inference provides persistent endpoints with sub-second latency. The endpoint is always running and ready to accept requests. It supports payloads up to 6 megabytes. This is ideal for interactive applications, APIs, and any use case requiring low latency responses. You pay for the instances as long as the endpoint is running.
Serverless inference eliminates infrastructure management entirely. Endpoints scale to 0 when idle and auto-scale based on traffic. You pay only for the compute time used during inference. The trade-off is cold start latency when scaling from 0. Payloads are limited to 4 megabytes with a 60-second processing time limit. This is perfect for intermittent or unpredictable traffic patterns.
For large workloads, Sagemaker offers async and batch inference. Async inference queues requests and processes them asynchronously. It supports payloads up to 1 gigabyte and processing times up to 1 hour. Results are written to S3. Batch transform is for offline bulk processing. It manages the entire compute lifecycle, spinning up instances, processing your data, and shutting down. No persistent endpoint is needed.
Invoking an endpoint is straightforward. Use the endpoint object returned from deploy. Call invoke with your request body and content type. The response contains the prediction results. For real-time endpoints, you get immediate responses. For async endpoints, you receive a reference to the S3 output location instead. You can also configure custom serialization and deserialization logic.
Machine learning operations, or MLOps, is critical for production ML. Sagemaker provides a complete MLOps toolkit, including pipelines, model registry, feature store, and experiments.
Sagemaker Pipelines lets you define ML workflows as directed acyclic graphs. Processing step handles data preprocessing and feature engineering. Training step runs your model trainer with the new V3 API. Model step registers trained models in the model registry. Condition step enables conditional branching based on metrics. Tuning step runs hyperparameter tuning jobs. And quality check step validates data and model quality automatically.
Here is how you build a pipeline in V3. Import pipeline and training step from sagemaker.mlops. Create your model trainer as before, then call train to get training arguments. Wrap those arguments in a training step. You can also create processing and model registration steps. Chain the steps together in a pipeline, upsert it to create or update, and start execution.
The model registry provides centralized model version management. Each model package group holds multiple versions of a model. Every version includes metadata, evaluation metrics, and approval status. The approval workflow supports pending manual approval, approved, and rejected states. This integrates with CI/CD pipelines for automated deployment on approval. You can attach model quality metrics and bias reports for compliance. Sagemaker Feature Store manages your ML features across training and inference. The online store provides low-latency reads for real-time inference, typically under 10 milliseconds. The offline store persists historical data in S3 for training. You define feature groups with schemas and ingest data from data frames, S3, or Spark. The feature store ensures consistency between training and serving, eliminating training-serving skew. Sagemaker now integrates with MLflow for experiment tracking. You get a fully managed, serverless MLflow tracking server. Log parameters, metrics, and artifacts from any training job. Compare runs side by side with interactive visualizations. The traditional Sagemaker Experiments API is still available, and MLflow model logging integrates directly with the Sagemaker model registry for seamless deployment. Let us wrap up with critical best practices for cost optimization, security, and production deployment patterns. Cost optimization is crucial for production ML. Managed spot training can save up to 90% on training costs by using spare EC2 capacity. Right-size your instances by profiling before choosing instance types. Use serverless inference for endpoints with intermittent traffic to avoid paying for idle compute. Multi-model endpoints consolidate multiple low-traffic models on shared infrastructure. And Sagemaker savings plans offer up to 64% savings with committed usage. Security must be built in from the start.
Enable network isolation for training containers to prevent data exfiltration. Use VPC configuration for endpoints to keep traffic within your private network. Encrypt data at rest with KMS and in transit with TLS. Apply IAM roles with least privilege access for Sagemaker resources. And enable CloudTrail logging for a complete audit trail of all API calls.
For production deployments, use proven patterns. Blue-green deployment enables zero downtime updates by switching traffic between two identical endpoints. A/B testing deploys multiple production variants with configurable traffic splitting. Autoscaling configures target tracking policies to scale based on invocation volume or CPU utilization. And model monitoring detects data drift and model quality degradation in real time, alerting you before performance degrades.
Let us recap what we covered. The Sagemaker Python SDK v3 brings a modular, unified approach to ML. Model Trainer simplifies all training jobs with structured configs. Model Builder chains training directly to deployment. 4 inference options cover every use case, from real-time to batch. Pipelines and model registry enable robust ML ops. And cost optimization and security practices keep your ML workloads efficient and safe. Thank you for watching, and happy building.
Thank you for watching this deep dive into the Amazon SageMaker Python SDK version 3. This presentation was simplified by Omar Hasni. We hope you found it valuable and are ready to start building with SageMaker. Happy machine learning!